students, welcome to my YouTube channel, and in today's video we are going to solve some most important questions on refraction part 1. So the link of the video will be given in the description box. Check it there. So today's first question is, a girl uses blue and orange light to find the refractive index of glass respectively. Will the refractive index be the same or different in two cases? Look, these 7 questions all are very important, and this will completely clear your concept on the first part of refraction, and I hope you will enjoy the session. These 7 questions will cover the whole thing, and you must listen to me carefully to understand the whole part of this. So the first one I have already read out, and here we are using light blue and orange. So previously in refractive index in that video I have discussed that I have compared two light blue and violet and red, and where I have shown you that wavelength of red light is very greater than wavelength of blue light. Now violet light, So in this case the wavelength of orange light is quite greater than blue light, because we all know that is the VGR. You have probably read about it. It is the rainbow colors, the short form of rainbow colors, where V stands for violet, I indigo, B blue, G for green, Y for yellow, and O orange, and red, R for red. Now in this line the wavelength will increase. Now so if we see this, we will find that wavelength of orange is greater than wavelength of blue light, and the question is given that a girl uses blue and orange light to find the refractive index of glass respectively. Now I have also told you one thing, that if wavelength increases, as it increases from blue to orange, as wavelength increases, the velocity of light will increase, because wavelength and velocity has a proportional relationship. Velocity of light will increase, and in refractive index I have told you that if light falls in angle I, angle of incidence, this is the angle of incidence, and when it go through the second media, if the velocity increase, it will bend away from the normal, but if the velocity decreased, from one media to another medium, the refracted ray will bend towards the normal. So in this case, as the wavelength is changing from orange to blue, so if we just draw their pattern, we can see that refractive, this angle of incidence is same for the two light, suppose, and for the first thing orange, as the velocity of light is greater than that of blue, we say that in that case the angle of refraction, and here the angle of refraction. So in this case the angle of refraction for orange light is greater than angle of refraction for blue light, because as the velocity is greater in case of orange light than in case of blue light. So we get that though in angle of incidence is same for the both light, but the angle of refraction is not same, and it is greater for orange light than for blue light. Now, so we know that mu refractive index is equal to sin I by sin R. That is the Snell's law. I have told about it already. Now, as the sin R is increasing from orange to blue, or you can say that we know that sin 0 degree is equal to what? Is equal to 0. Sin 90 degree is equal to 1. So we can see that for sin from 0 degree to 90 degree, the value of this sign will increase from 0 to 1. So if the value of sin R increase, definitely the denominator part will increase, and as from orange to blue light, as the angle of refraction is increasing, the sin R is also increasing. That is why the denominator is getting greater than numerator, or you can say here the value of sin r is increasing. So in this case, if we get a value, suppose 0. So suppose here the angle of incidence is 1 and sin r is equal to suppose 2, and for orange light, okay, and here as this and here for blue light this is suppose 1. So what you can say, the denominator is increasing from, denominator value is decreasing from orange light to blue light. The value will be 0.5 in this case, and it will be 1 for your blue light. So finally I can say you that if the girl uses blue and orange light to find the refractive index of glass respectively, the refractive index will be higher when the girl will use blue light. When the girl will use orange light, it will be lower. So I hope you understand the question. Now look at the next question. When the glass will be invisible if the girl uses only one light, what will be the angle of refraction and delta, that is deviation, then? So previously in my earlier video, the link I have given in the description box, so I have told you that there is only two cases where any object will be invisible, okay, in any medium, and the two cases are, first one, when the light will fall normally like that. Suppose this is the surface between two medium, air and glass, and if a light fall along this normal, there will no angle of incidence. Angle of incidence will be 0 for this case, and as there is no deviation, so here the delta is 0, and finally the glass will be invisible as there is no deviation, because in case as from one medium to another medium, as refraction works and there is a deviation we found from going one medium to another medium, it is for the second object, the another medium become visible to us. So if the deviation is somehow stopped, there the second medium will be invisible definitely. So in this case the same thing is happening, as we are making the deviation 0 over here, and thus the second medium, the glass medium, is becoming invisible over here. And the second case is when the refractive index will be same for both medium. Suppose this is the air medium and this is the glass medium. If somehow make the refractive index of both mediums same, in that case it will be invisible. The second medium will be invisible. For example, your air and glass, there will no deviation will occur. Okay, just suppose a light will pass in that way and there is no deviation, as the refractive index is same for the two medium. Okay, so I hope you understand the question. Next, move on to the question number 3. When a candle is held in front of a thick glass mirror, several images are seen, out of which the second image is brightest. Give reason. Now we all know that this is your mirror and there is a silver surface is and the another side of mirror. So suppose there is a candle and the light ray is going from here and it fall in this line, and there we will draw the normal. This is your air medium and this is the glass medium of mirror. And now one part of the light will reflect back in this way, but another part of light will be refracted. And as we know that the velocity of light changes from air to glass, it is decreasing, so definitely the refracted ray will bend towards the normal, and when it will reach at the silver surface, it will completely reflected. And when the light will reach here and incident in another part of the mirror where there is no silver surface, this will again refracted, and in this case the light is moving from glass to air and the velocity is increasing. So the refracted ray, if we draw normal along this point, the refracted ray will move bent away from the normal. So thus, are you getting that we are getting two images? We are getting two images over here. First one is here and the second image is here. Now, it has been found that only 4% of reflection occurs for the first incident of light, and this is so the 96% ray, 96% of this light will be reflected. So for this case, as the 96% of light is also refracted over here, simply we say that the intensity of light is greater in this case, where it will be lower in this case as there is only 4% of light is over here. So finally we conclude that the second image that has been got after second times of refraction is the brightest. So I hope you understand the thing. Now next move on to the question number 4. So suppose you put the mirror under water, show the path of the ray in diagram after it strikes the mirror and re-enters in air. Also mark the angles wherever necessary. Now suppose that is your mirror and we are keeping it under water. So suppose a light ray is incidenting. A light ray falls here and we will draw this normal along the point, and as this is your air medium and this is water medium, so definitely the light ray will change its direction and it will bend towards the normal, and thus when it will strike the mirror for the first time, it will be reflected back to the surface of air and water, and there, so this is the point of incidence. So we will draw the normal along this point, and when it will move from water to air medium, as the velocity of light is increasing, this ray will slightly bend away from the normal. So here this is the angle of incidence I. This is the, okay, I will also draw a normal over here as this is also a point of incidence, and this is the angle of refraction, and this is the angle of refraction for the second time. Okay, and now what is the deviation? So are you getting that here we are getting, if we just extend the line like that, this will be the deviation delta, and here also if we extend the line, the deviation will be this one. Okay, so here we say that delta is equal to R minus I, as here the angle of refraction is greater than the angle of incidence, and here in the first case delta will be I minus R, where the angle of incidence is greater than the angle of refraction. This is the angle of refraction and this is the delta. It is a deviation from the direction of incident light to the refracted light. Okay, so I hope you understand the thing. Now next move on to the fifth question. The speed of light in water is 2.25 into 10 to the power 8 meter per second. Find out the refractive index of water. Okay, so here actually you are asked to determine the refractive index of water, or the absolute refractive index of water. So what is absolute refractive index of water? I have already told you. You will answer me in the comment section. So now we all know we can write this as A mu W. That is the refractive index of water with respect to air, can be written as mu W by mu A. Now I have already told you that with respect to which we have to determine the refractive index of any medium. The first medium, the former medium, will be at the denominator position. Okay, so from this we also know that mu w can also be written as c, where c is the velocity of light in air medium by the velocity of light in water medium, and mu a, that is the refractive index of air, can also be written as the c by va. So finally we can say that c by vw by c by va. So finally it will be va by vw. So this is the rule, and now it has been given that the velocity of the speed of light in water is 2.25 × 10⁸ meter per second. So the denominator value is given, and we all know the velocity of light in water, the velocity of light in air, 3 × 10⁸ meter per second. So finally it will be 3 by 2.25 and then 100. So if we calculate, we'll find that it will be 1.3. Okay, so this is the refractive index of water. Actually, it is the absolute refractive index of water. Now next move on to the sixth question. If the refractive index of water with respect to air is 4/3, what is the refractive index of air with respect to water? Now, there is a principle, that the principle of reversibility of the path of light. So, for a quick recap, I am saying that suppose light ray is entering from air medium to water medium, and here there is a deviation of or the change in direction of light ray, and now this is the angle of incidence, this is the angle of refraction. Now we all know that mu, suppose this is air medium and this is water medium, so we all know that a mu w is equal to what? Sin I by sin r. This can be written according to Snell's rule. But if we reverse the path, suppose the light is moving from water to air medium, so complete thing will get reversed. In this case, we will write that W mu A, that is the refractive index of air with respect to water, is sin R by suppose sin I. We are writing that this is this angle. We are considering that this angle is angle of incidence, this angle is I, and this angle is R. So we can write it like that. So finally, if we multiply them, it will be it is 1. So we can say that A mu W is equal to 1 by W mu A. So if the refractive index of any medium, suppose for water medium, the refractive index of water medium with respect to air is A mu W, and it is your suppose 4/3. So the refractive index of air with respect to glass will be what? You are to determine the refractive index of air with respect to water. This one. So if it is 4/3, 1 by W mu A, so W mu A is equal to what? 3/4. That is the answer. Okay. Now next move on to the seventh questions. A ray of light of lambda wavelength 5,400 angstrom refraction from air to water, refracted from air to water, taking A mu W, that is the refractive index of water with respect to air, is equal to 3/2. Find the wavelength of light in water. Now, we all know that there is a relationship between lambda and mu. This I have already told you that it can be determined in this way. Suppose if a ray of light of frequency f and wavelength lambda suffers a refraction from air to a medium in which the speed of light is v. So I have already told you about the relationship. It says that if a ray, suppose moving from this medium to this medium, and in this medium the velocity of ray is v, but in this medium the velocity of ray is c. Okay. So now, and suppose it has a frequency f. Now we all know that frequency has, because frequency is only depend on the source of light. So in this case, where the wavelength will be lambda. Okay, and as the velocity is changing, the velocity is suppose decreasing in this medium. Suppose the wavelength will be lambda dash. So finally, in this medium we can say, as we know the relation that lambda is equal to fc. So finally we can write that f is equal to lambda by c for the first medium, and for the second medium we can also write that. So for the second medium where lambda dash will be v into f. So here you can also write that f is equal to lambda dash by v. So finally it will be f is same for all, and we can write that lambda by c is equal to lambda dash by v. And if we just move it, we find that lambda dash is equal to, so finally we will get that lambda dash is equal to lambda by lambda into v by c. So finally it will be lambda dash is equal to lambda by mu. As you all know that c by v is equal to mu, so it will be lambda by mu. Okay, and if we write the thing that lambda is equal to your 5400 angstrom into a mu w. This is a mu w actually according to this question. So it will be 2 by 3. Okay, and finally final answer will be 3600 angstrom. Okay, so as are you getting it? So the lambda, the wavelength of the light in water will be 3600. So I hope you understand the questions. So if you have any doubts, please go to the comment section, ask me, or you can mail me. I have given my mail address in the description box. So thank you for watching.